Let's now tackle the first problem of recursions on arrays. Specifically, we want to determine if an array of integers are all positive, meaning that if all the elements in the array are positive, you're going to return true for the method. Otherwise, if you can find at least one number that's non-positive, i.e. negative or 0, in that case, you're going to return false. Given that it's your very first exercise of recursions on arrays, so why don't we give you some further hints before you pause the video? Let's take a look. Let's look at some examples first. What about empty array? Well, in the empty array, you can think in this way. Since you cannot find any negative or 0 value in the array, in that case, it must be all positive. Logically, that's how you argue. So that's why it should be true. What about this array over here? You can see every element there is simply positive. So that should be true. All positive. What about here? You can find a witness, which is a counterexample to contradicts the fact that it's actually all positive. So that's why it should be false, right? So that's a very simple set of examples to show you how the method should work. All right, let's now give you further hints, given that it's your first exercise on recursions on array. What about base case? Well, there should be only one single base case for you to consider, just about empty array. Well, in the case of empty array, as we explained already, you should just return true, because you cannot find any witness or counterexample to prove that it's all positive, right? So that's why it should be, you cannot find a counterexample to prove that it's actually not all positive. So you must be all positive, right? You can read over this description over here to convince yourself. What about the recursive case? That means we got some non-empty array. In that case, what we should do is like this. We should somehow define what a strictly smaller problem is. So maybe something like how we did for example, the counting the number of occurrences on the string, which is an array of characters, which really talk about the first elements versus the tail of the array, meaning everything except for the first elements. So what we should do is, let's look at the first element there. The first element must be positive, right? And meaning that we're going to use conjunction. The rest of the array is all positive. So you can see the rest of the array is like the tail of the array, meaning that everything except for the first elements. In that case, it's really a strictly smaller problem to solve. So that's where we can call the recursion. So that's about the hints. And you can now feel free to pause the video and think about how you may actually sketch out the solution, or even better, if you can simply program the method in Eclipse if you want. Alright, pause the video and think about it. Assuming that you thought about it, let's now go over the solution code together for this is all positive recursive method. Okay, let's take a look. So this will be the Java code that's also included in your slides, but I'm going to go over in detail about the various components for recursion, and we're going to trace a number of example arrays. That's what we'll do to make sure you understand this example completely. So we are declaring this method here. Let's see here. All positive over here. So this is the method, right? And the input is simply a single array over here. And it's a very typical solution to this kind of whenever you want to declare, you want to define some recursive solution on array, you want to declare so-called recursive helper methods. That's what's really happening over here. So if you look at all positive helper over here, you will see that this method here, at some point you can see the method is actually invoking itself. So that's why it is recursive, and that's also at the same time a helper method. So that's why it's called a recursive helper method. So it's a recursive helper method. So this is a very common way to actually solve problems recursively. Okay, let's now take a look. So you can see call by value. So we are passing just the reference of the input array, and then we are giving the minimum possible index and also the maximum possible index, as we actually explained earlier, right? So you can see here, this is the minimum possible index, and this is the maximum possible index. If effectively, we are really trying to we are trying to have a range that's between the minimum and maximum indices, covering all elements in the array. That's basically what we're doing. So this will be the minimum index, and this part here will be the maximum index. Okay, so if you imagine that A is an array that looks like this. If you take a look like that. If A is like this, and let's say index 0 over here, and this will be maybe A.length minus 1. A.length minus 1. So over here, when you say from 0 all the way until A.length minus 1, our intention is to scan through the entire range of the array, right? That's what we have got so far. All right, and then you can look at the parameters for the recursive helper method. It would be the integer array taking the reference call by value, and also the from, and also to over here. Okay, let's now take a look at the base cases. So these are the base cases, the first two. So these are the two base cases. You can also look at the comments I put there. So this is this part here is the these are the base cases. Specifically, if you got from is larger than 2, as we explained before, and we'll trace the code a little bit later. From larger than 2 means that it's an empty array. And in the case of the empty array, since we cannot find any counterexample like a positive, we cannot find any counterexample, either a 0 or a negative number. In that case, we just have to return true. There's no counterexample to disprove that the array is all positive. So that's why it must be all positive. That's kind of the logic. And this part here, from equals 2. So this one here is really handling, let's say, an array of length 1. In which case, all we got to do is we have to make sure the only element in the array is actually positive, right? So that's why we put something here, right? It's you can say A at index from or A at index 2. Doesn't matter because from is equal to 2. In that case, we want to make sure the only elements in the range or in the array is actually positive, right? So these are the two base cases. What about the recursive case? The recursive case, first of all, is over here. So this part over here is the recursive case. Okay, so this is the recursive case. Recursive case over here. And let's take a look at the recursive case. So what we're doing here is we are saying that in order for all the elements in the array to be positive, the first element must be positive, right? You can think about what we're doing here is given some from and to. Given the from value over here, okay, let me just try to use the same color. Given from and given to. Let's say the from in the beginning is actually here, and to in the beginning is over here, and we want to make sure the first element there is actually larger than 0. So we are saying that this part here must be larger than 0. Not only that, so we want to use conjunction over here, right? It's really important to see why we're using conjunction rather than disjunction. And this part over here is to make a recursive call on the rest of the array. So the rest of the array is going to be from plus 1, right? So from initially is simply 0. From plus 1 is going to be at index 1. So this will be from plus 1. And all the way until and including 2, which is this part. So you can think about this is the part that we are talking about. So this is the part that we are talking about over here. So this is like the tail of the array. In which case, we want to make sure it is all positive, right? You can see we're calling all positive helper over here, right? Making a recursive call on this subproblem here. Okay, let's just make sure, okay, like that, okay? And we want to make sure this part over here is really all positive. Okay, so this part we are calling the helper method all positive helper. Okay, and then etc., right? That one is actually going to cover the rest of the array. So not only that, the first element must be positive, but also the rest of the array must be all positive. And the way for us to solve this strictly smaller problem is by making a recursive call over here. All right, so that's a very quick walkthrough about the code itself. And you can see we are just following the pattern which was explained in the earlier video. That's something you should really refer to. But to really strengthen your understanding, let's now go over a few test cases just to make sure you understand how the code should be executed. Let's look at 4 test cases. The first one, let's say the input array A is simply just empty array, right? So now if A is simply the empty array, by definition, we're going to call this recursive helper method, and then we're going to put, so -1 over here is really the A.length -1, right? So it's going to be A.length -1. A.length in this case is actually, what's the length of empty array? Well, it's simply just 0. 0 minus 1 is going to be -1. So that means we're calling this with 0 and then -1, right? That's what we're doing. And if you try to see this, 0 larger than -1. 0 larger than -1, that's actually true. So that means we're going to execute this base case over here. So the execution path over here is actually rather straightforward. We haven't gone through any recursive code just yet. Given this particular input, the execution path will be, we're going to execute this recursive helper method, and then we're going to reach this particular base case and then return true. That's the first tracing, the tracing for the first input. All right, let's go to the second test case. Let's say this time we got an array of a single elements over here. Let's see what an execution path might be. So what we'll do is we're going to pass A, which is a single elements array over here. And then this part here is always 0. And this part here is going to be A.length -1. Okay, which will be, well, the length of the array is simply 1. 1 minus 1 will be 0. So that's why you see 0 over here, right? So what's going to happen is you got 0 here, 0 here, 0 here, 0 here, and we don't really satisfy this branch over here. 0 larger than 0 is actually false, so we don't execute this branch. Instead, we're going to execute this base case over here, because 0 equals 0 is actually going to be true, right? Let me just highlight the execution path for you first. Given that it's a single element array, we're going to execute the recursive helper method, and then we're going to reach this particular line. Okay, of course, you still have to evaluate this to make sure it's actually false. So we will skip the body of the branch. And when we evaluate the second branch, we're going to execute this particular line. Okay, and that one is going to correspond to A0 over here, right? Because from value at the moment is actually 0. So A0 larger than 0. So if you think about what's happening here, this is A, and this is the input array with only a single element at index 0, and the element there is actually 4, right? And what we're having is, in the beginning, we got from and to, both being 0. You can think about conceptually from and also to are really the same value. So that means we're really restricting ourselves to this particular range of the array. In that case, we just have to compare to see whether or not this particular value is actually larger than 0. That's why A at index 0, is it larger than 0? It is, because 4 is larger than 0. So that means this part over here is going to be true. That means you gotta return true from over here, right? Okay, and that makes sense because it's all the elements in there positive. Indeed, they all are positive because there's only one element there that's positive, of course. All right, let's now take a look at 2 more slightly more complicated cases. Okay, the case number 3 over here. Let's take a look. You can see 4739. So eventually we're going to know it's going to return true eventually. But let's see exactly what's going to happen. Let me first draw the input array. You can see this is the input array A, 4739, right? So let's put A is pointing to the starts of the array of size 4. Okay, 0, 1, 2, 3. So 0, 1, 2, and 3. And what about the elements there? Let's put the element there. Okay, it's going to be 4, 7, 3, and 9. Eventually, we can predict that it's going to return true because all the elements there are simply positive, right? But let's now trace the code to see exactly how the recursion is going to be unfolded. Let's see. So we start with this particular call over here. We're going to pass a call by value, So A is going to be passed over here, right? So this part over here would just be A. And then we're going to say 0 to A dot length minus 1. So our intention really is, to be more precise, you can see A dot length in this case will be 4. 1, 2, 3, 4. Okay? A dot length minus 1 is going to be 3. Meaning that we're going to go from index 0 to index 3. That's our intention. Okay? So this one is going to boil down into calling the recursive helper method with from 0 to 3. Right? You can see from 0 to 3. Diagrammatically, what we really intend to do is to go from index 0 to index 3 over here. Okay? So we start with that. So it's going to be from 0 to 3. Okay? As you can see, 0 and 3. 0 larger than 3? No. 0 equals 3? Also no. So we're going to go into the recursive case, right? So we're going to bypass the base case, bypass this base case, but we're going to go to execute this recursive call, which will be, over here, is going to be A from larger than 0, right? So this part over here, A from larger than 0. From is simply just 0 over here, right? So A0 larger than 0 is exactly what you see over here, right? A0 larger than 0. And then what about this part over here? So we're going to make a recursive call. Let me use a different color. So we got green. How about we got pink? Okay. So this is going to be the first recursive call over here. So we're going to call this, and what will be from plus 1? From plus 1 will be 0 plus 1. So it's going to be from 1 to 3. So that's the pink, right? So the pink, this new recursive call is really intends to go from index 1 to index 3. Index 1 to index 3. So diagrammatically, we really intend to go on this particular strictly smaller problem. That's what we intend to do, right? Okay, so let's go from 1 to 3 over here. And what would this recursive call boil down into? Let's take a look. So what's going to happen is we got 1 and 3. So that means the from over here is going to be 1, and also 2 is going to be 3. You can see the 2, in this case, remain the same. Okay, let's now take a look. So we got 1 and 3 to be the from and 2. So 1 larger than 3 is actually false. 1 equals 3 is also false. So that means we're going to go into the recursive case, right? So we bypass this base case, and we're going to execute this recursive call for the second time. And specifically, let's and in this case, from is actually 1. So that means we got A at index from, so that'll be A at index 1 larger than 0, right? So that's exactly what you see over here. A 1 larger than 0. It is this part over here. Okay. What about the recursive part? The recursive part in here is going to be from plus 1. Let me use a different color again. Let me use orange. From at the moment is actually 1. By adding 1, so it's going to be 2 and 3. So what does that mean diagrammatically? So you want to go from 2 to 3, which is going to be this particular array, this particular sub-range of the array. But what conceptually you can think about it is more like a strictly smaller problem of the array. So we want to go from 2 to 3. So that's exactly this call over here. Okay, and we are not done yet. We haven't really reached the base case just yet. Let's now move on further. So that means we're gonna call this helper method the third time. So this will be 2 and also 3 over here. So 2 and 3. 2 larger than 3 is false. 2 equals 3 is also false. And so that means we're gonna execute the recursive case for the third time. Let's now write it down. So we don't execute the base case, and we're going to execute the recursive case for the third time. Now, we're going to also do from plus 1. Before that. So the current value for from is actually 2. So that means A at index 2 larger than 0. That's something we got to evaluate as the left-hand side for the conjunction, right? So that's why you will see actually A at index 2 larger than 0, right? That's really correspond to this index over here. And what about the recursive call over here? And that one there, let me just use one more color. What about blue? Okay, so let's see the blue. And it's going to be from plus 1. You see from plus 1. From value is actually 2, right? So now it's going to be 3 and also 3. Okay? 2 simply remains the same. So 3 and 3. So 3 and 3. Diagrammatically, what we really intend to focus on will be this particular strictly smaller problem, right? You can see we keep reducing the sizes of the subproblems to make sure each time you make a recursive call, the subproblem is strictly smaller. Okay, let's now move on to finish. So we got 3 and 3, and we're gonna execute this recursive helper method for the 4th time, right? And we're going to put 3 and 3 over here, and now we got 3 and 3. 3 larger than 3 is false. 3 equals 3 is going to be true. That means we're going to execute this particular base case, right? Let's now annotate it. We don't execute this base case, but we're going to execute this base case as instead. So because from is equal to 2, and then we're going to return a at index from. In this case, from will just be 3, right? So a at index 3 larger than 0. So this part over here, right? This part here from 3 to 3 is going to boil down into the following. Let's now write it down. Okay, it's going to be unfolded into this particular base case as we mentioned. From is actually 3, so a3 larger than 0. Okay, and now it's time to return. Let's see what's going to happen. A3 larger than 0. So what's A3? A3 larger than 0, 9 larger than 0 is actually true. Right? It's actually true. And then we actually got n%, right? Every level is actually about evaluating n%, the conjunction. A2 larger than 0 is something we got to evaluate from before. A2 is actually 3. So 3 larger than 0 is actually true. So this part over here is actually true. True and true is going to be true. So this will complete the evaluation for this particular recursive call, right? So this part here will just be true. And then what's A1? So now we are trying to evaluate this particular recursive call, like a higher level. So A1 is actually this particular elements, which would be 7. 7 larger than 0 is actually true. So we got true and true is going to be true. So that means this part here is going to be true. Okay, we're almost done. And then here we got A0 larger than 0. A0 is 4 over here. And then 4 larger than 0 is, well, true. So we got true and true. Eventually we got true over here, right? The ultimate result that will be returned from this particular recursive method call is going to be just true. That'll be the eventual result. So I think things already get reasonably complicated already. I think if we didn't actually stick to this high level tracing, if we are still using the the call stack to really trace the method call, it's so easy to really get confused and also get lost. So I'm hoping that this is really high level enough and also enough for you to really see exactly how the recursion will go. Okay. All right. So that's about the detailed tracing for all positive. As an exercise, I got another input array for you. We got 5, we got 3, we got -2, and we got 9. So at some point, we will actually expect maybe at A012, A2 larger than 0 over here is going to be false, right? In that case, it's not really necessary because of the short circuit evaluation to go any further once we get to this level, right? So as an exercise, I would like you to do the tracing on your own, right? If you got any trouble, you can let me know. Exercise. And you should really try to trace this particular code. So that'll be the exercise I assigned to you. All right, that's what I would expect you to do. Let's now go back to the slides, okay, to conclude the example. Another exercise I will assign you to do is another one. Let's say we define another Boolean method that will return another method that will return a Boolean value that's called a sum positive. It's almost like an opposite problem to be solved. Given an input array over here, we want to solve recursively, and we want to return true if there's at least one positive number A, and false if there are no positive values in A. So that will be the opposite to the all positive problem that we had just solved. I'll leave that to you as an exercise. And some hints for you. What should you return in the base case where the array is simply just empty? In the empty array, can you find any element that's actually positive? No, you cannot. So that would be simply false. How can you find any elements from in an empty array? You cannot, so that you cannot prove that you can actually get at least some positive, so that means it must be false. Okay, so that's about the first example. Hopefully you are still following, right? But I would say it's rather important for you to really appreciate that you actually got this kind of a high-level tool to help you understand the behavior of the recursive method over here, especially to really define something, some method that will take only a single array. In order to implement it efficiently, recursively, we have to define this recursive helper method, which we already explained conceptually in the earlier video and also in detail on a concrete example in this current video. Right? You want to really review both to make sure. All right, let's now go on to the last problem to be tackled for recursions on array. Okay, so that's the code. And let's now take a look at the second problem.